Section 10.1, Multiple Predictors, Video 3. Okay, so I changed my mind. At the end of the previous video, I said we were going to recycle the computer output to answer some more questions, but that will be later in this series of videos. However, I am going to use the regression equation that we built from that computer output. So the same regression equation that we had before, the predicted price of a printer is equal to 89.20 plus 58.10 times the ppm, the speed in pages per minute, minus 21.125 times the cost BW, the cost in cents to print one black and white page. Excuse me. In this section, I want to interpret the slope. Now, we had interpreted slopes previously when there was only one explanatory variable. For example, if this last term wasn't here, this slope would be the predicted change in price if the printing speed increased by 1. And the interpretation is pretty much the same, but you have to mention the other explanatory variables as well. So basically, when you interpret a slope, it starts out the same way. First, we got to pick a slope to interpret. So let's interpret the Ppm slope. We start interpreting it the same way as before. If the printing speed, which is what ppm is measuring, increases 1 page per minute, but here comes the change, and the cost to print one black and white page remains constant, and that's the twist. Then we predict the price will increase by this amount, $58.10. So there's 3 parts to interpreting the slope in a multiple regression. Number 1, you have to state that the explanatory variable whose slope that you are interpreting increases by 1 whatever. So if this increases by 1. But you also have to state that everything else stays the same. So, and the other explanatory variables don't change, they remain constant. In this case, it's just 1. We could say generically, and the other explanatory variables remain constant. If there were 4 of them, I wouldn't want to say if this remains constant, and this one remains constant, and so does that one, and so does that one. We could just say everything else remains constant. Then the interpretation of the slope is the same. You predict that the response variable will increase or decrease by whatever the amount is. Increase if the slope is positive, decrease if the slope is negative. So it's the same interpretation with the addendum that everything else stays constant besides the one variable whose slope you are interpreting. So how would we interpret the other slope? I want you to think about it for a second. Literally say out loud what you think the sentence would be. I'll pause and go crack open my Diet Pepsi while you do that. How would the interpretation of the slope for the cost of one black and white page go? Well, it would pretty much shut out the same, except you would say if the cost to print one black and white page increases by 1 cent, because remember this is measuring in cents, and the printing speed remained constant, then we predict the price to decrease $21.13 if we round it off. So interpreting a slope is just like it was before. If this goes up by 1 and everything else stays the same, then we predict the response variable will increase or decrease by whatever that slope is. So pretty straightforward. Just one an addendum about the remaining explanatory variables being constant.